This is SpaceTime, Series 25, Episode 3, full broadcast on the 7th of January 2022. Coming up on SpaceTime, Solar Orbiter publishes a wealth of new science results from its cruise phase, how NASA's Mars Curiosity rover is making the red planet safer for astronauts, and we look at Electron's big brother, the neutron rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists are busy sifting through a wealth of data which has come from the European Space Agency's Solar Orbiter mission, which is studying our local star, the Sun. The new data is included in more than 50 separate scientific papers which are reported in the journal Astronomy and Astrophysics. Forensic observations of the solar surface, measurements of a giant outburst of energetic particles, and an encounter with a comet's tail are just some of the highlights. And all this has come from the spacecraft's cruise phase, before its primary science mission even gets underway. Launched in February 2020, Solar Orbiter's cruise phase began on June the 15th that year and continued until the end of November last year, when its science phase officially commenced. During its cruise phase, Solar Orbiter acquired scientific data using instruments which are designed to purely measure the environment around the spacecraft itself. It also used its remote sensing equipment to look at the Sun in order to characterize and calibrate those instruments. Some of these data turned out to be of such good quality, they enabled the first scientific studies to be undertaken well ahead of the main science phase. For example, Solar Orbiter's Extreme Ultraviolet Imager discovered a series of miniature solar flares that scientists have nicknamed campfires. Now, these could play an important role in explaining the million-degree temperature of the Sun's outer atmosphere, the corona, which has defied explanation for decades. After all, the Sun's surface has a temperature of around 6,000 degrees. Yet the temperature of the corona goes up into the millions. And that's caused scientists to scratch their heads because things are supposed to get cooler the further they are away from a heat source. In the latest results, the instrument's been acquiring observations in a high cadence mode, returning images of the solar corona every 2 seconds. These sequences are among the highest cadence observations of the solar corona ever recorded in extreme ultraviolet. The data reveals a dynamic class of campfires that shoots out jets of electrified gas known as plasma at speeds of hundreds of kilometers per second, but lasting for just 10 to 20 seconds. And the view will only continue to get better as Solar Orbiter gets closer to the Sun. As well as these small-scale campfires, Solar Orbiter's also witnessed its first large-scale event. On November the 29th, 2020, the first widespread energetic particle event for several years burst forth from the Sun. See, our Sun goes through an 11-year solar cycle of magnetic activity, and it's been at what we call solar minimum, the low point in its cycle, for some time now. And so this solar eruption, which heralded the start of solar cycle 25, spread energetic particles across the entire inner solar system. In fact, by the time the eruption reached Earth's distance, the ejected particles were spread over more than 230 degrees of solar longitude. And they were detected not only by Solar Orbiter, but also by NASA's Parker Solar Probe, NASA's Stereo A spacecraft, and the joint NASA and European Space Agency Solar and Heliospheric Observatory spacecraft SOHO, all of which are close to Earth's orbit but at varying solar longitudes. So the question is, how big was this event source region on the Sun, and how much did the eruption expand after it was released? Astronomers also searched for a triggering event associated with a coronal mass ejection which occurred in April 2020. Now, coronal mass ejections, or CMEs, are violent explosions of charged particles in magnetic field associated with solar flares erupting from the Sun's surface and blasting into space. So, scientists looked for an associated solar flare. But despite the magnetic field strength measured by Solar Orbiter being especially large and around double that of a normal CME, the solar surface remained completely blank at that time. There were no sunspots and no other active regions. It was only the high magnetic field strength of the plasma that engulfed the Solar Orbiter that alerted scientists to a CME in the first place. After a painstaking search of the data, scientists eventually found a dark region in the extreme ultraviolet, indicating a low-density cavity in the solar corona that lifted off very slowly from the Sun. Now, in this context, slow is a relative term. Whereas most coronal mass ejections travel at hundreds or even thousands of kilometres per second, this one was moving outwards at just tens of kilometres per second. From a space weather forecasting perspective, these stealth CMEs, for want of a better term, are going to be a special challenge. That's because forecasters have always relied on seeing something on the Sun that they can recognise in real time, such as sunspots or a solar flare, in order to know that something is incoming that might change the near-Earth space environment. Solar Orbiter's course also saw it cross the tail of the comet Atlas during June 2020. However, in a cruel twist of fate, the comet disintegrated under the heat of the Sun just 10 days before the crossing, and the tail faded. Nevertheless, astronomers still found evidence consistent with the crossing of a comet's tail remnant in data taken on June the 4th. They saw the magnetic field around the solar orbiter suddenly change polarity, which would be expected if the Sun's magnetic field were draped around a piece of broken comet nucleus. Following its November 2021 flyby of the Earth, Solar Orbiter is now on its main science phase, with a close flyby of the Sun to take place in March. We'll keep you informed. This is SpaceTime. Still to come, how NASA's Mars Curiosity rover is making the red planet's surface safer for astronauts. And we examine the Electron rocket's big brother. Enter the new neutron rocket. All that and more still to come on SpaceTime. A radiation sensor aboard NASA's Mars Curiosity rover is providing scientists with key data to help them prepare humans for life on the red planet in the next decade. The findings by the Radiation Assessment Detector, or RAD, will help researchers determine if lava tubes, caves, or other subsurface habitats could offer future Mars astronauts safe refuge from the soaking radiation which bombards the Martian surface. See, unlike the Earth, Mars doesn't have a magnetic field to shield it from high-energy particles in the solar wind and cosmic rays. And that radiation will pose a significant health threat for humans, as well as seriously compromising the delicate electronics in life support systems that haven't been especially hardened to withstand it as yet. Now, based on the data from Curiosity, scientists are finding out that using natural materials such as rock and sediments on Mars could offer some degree of protection. A report in the journal JGR Planets found that when Curiosity was parked next to a cliff at a location known as Murray's Buttes between September the 9th and September the 21st back in 2016, the RAD instrument measured a 4% drop in radiation levels. More significantly, the instrument detected a 7.5% decrease in neutral particle radiation, including neutrons that penetrate rock and are especially harmful to human health. Now, these numbers are statistically high enough to show that Curiosity's location at the foot of the cliff, rather than out in the open air, was enough to shield the car-sized six-wheel rover from at least some background radiation. Most of the radiation measured by RAD came from galactic cosmic rays, particles cast out by exploding stars which send them flying through the universe. This forms a sort of carpet of background radiation that can pose a real threat for humans. Then there's the constant stream of particles from the Sun and the solar wind, which bathes the entire solar system, and there are more intense radiation eruptions from the Sun in the form of solar storms, which throw massive arcs of ionized plasma into interplanetary space. These structures twist in space, sometimes forming complex croissant-shaped flux tubes larger than the Earth, driving shock waves that energize particles. Solar storms vary with frequency based on the Sun's 11-year solar cycle. Counterintuitively, the periods when solar activity is at its highest may well be the safest times for future astronauts to travel to Mars, as the increase in solar activity helps shield the red planet from deep space cosmic rays by as much as 30 to 50% compared to periods when solar activity is low. It's sort of trading one type of radiation for another. It's an issue scientists will still need to overcome before they can send humans to Mars. So far, RAD's measured the impact of more than a dozen solar storms, including 5 while travelling to Mars in 2012. However, those over the past 9 years have all been reasonably weak as the Sun was in solar minimum, the lowest point in its 11-year solar cycle. But scientists are now starting to see activity pick up again as the Sun moves into a new solar cycle and heads towards a new solar maximum and greater activity. In fact, the RAD instrument observed the first X-class solar flare of the new solar cycle on October the 28th. X-class solar flares are the most intense category of solar flares, the largest of which can lead to power outages and communications blackouts on Earth. RAD's findings will all fit into a much larger body of data now being compiled for future manned missions to Mars. These are being further supplemented by observations now being undertaken by Curiosity's sister Mars rover, Perseverance. Perseverance is undertaking its own readings and includes samples of potential spacesuit materials in order to assess how they hold up to Martian radiation over time. This report from NASA TV.
Seasons change even on Mars. A look at how NASA's explorers study the weather and cope with change. For most of them, measuring the weather is a key part of their job. It's early summer in Jezero Crater, where NASA's Perseverance rover and the Ingenuity helicopter are exploring the South Sator region. Perseverance uses its Mars Environmental Dynamics Analyzer, or MEDA, to measure temperature, humidity, wind speed, and direction. These wind sensors also measure the amount and size of dust particles in the atmosphere, helping scientists understand the dust cycle and its impact on weather. MEDA also provides the Ingenuity helicopter with critical pre-flight weather forecasts. Recently, warmer temperatures and a thinning atmosphere have made it more difficult for the helicopter to generate enough lift to fly. Its rotors had to spin faster than they had in previous flights, roughly 2,700 revolutions a minute. In the southern hemisphere, where the Curiosity rover is driving in Gale Crater, it's early winter. The Rover Environmental Monitoring Station, REMS, provides daily weather reports and takes regular dust surveys to measure seasonal changes over time. The InSight lander is focused on what's happening below ground. In September, it measured one of the biggest, longest-lasting Mars quakes ever detected. Seismic waves from the magnitude 4.2 shook InSight for nearly an hour and a half. Finally, the fleet of orbiters, including Odyssey, the Mars Reconnaissance Orbiter, and MAVEN, help scientists understand the scope and scale of storms from above. MRO produces a daily global weather map and provides us with amazing images.
This is SpaceTime. Still to come, Rocket Lab explains its new neutron rocket, and Starlink under fire for crowded skies. All that and more still to come on SpaceTime. Rocket Lab is developing a new launch vehicle designed to carry far bigger payloads than the company's current two-stage Electron rocket. The 18-metre tall Electron is designed to carry small payloads up to 300 kilograms into low Earth orbit. But it's quickly grown to become the West's second most frequently used orbital launch vehicle, surpassed only by SpaceX's Falcon 9. Rocket Lab's new launch vehicle, to be called Neutron, will be 40 metres tall and capable of carrying 8 tons into low Earth orbit in a reusable configuration or 15 tons fully expendable. The new rocket's being designed around a revolutionary new core stage. It'll be constructed out of 3D printed carbon composite and designed to be fully reusable. The core stage will be powered by 7 reusable liquid oxygen and methane-fueled 1 meganewton Archimedes main engines. They'll provide 320 seconds of thrust. Uniquely, the rocket's payload fairing, which will protect satellites during atmospheric ascent, will actually be part of the core stage and hinge to open up Hungry Hippo style rather than the usual separate expendable structures attached to the stack's upper stage. So after main engine cutoff, or MECO, the entire payload bay fairing will open up, allowing the upper stage and payload to deploy. The core stage will then return to Earth, landing vertically back at the launch site, while the upper stage and payload would continue onto orbit. Rocket Lab founder Peter Beck says construction on prototype tanks and other components is already underway, with the first Archimedes engines likely to be tested later this year. He says the first Neutron rocket could fly in 2024. Missions will take off from Rocket Lab's new launch complex at NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast. Beck revealed his thinking behind the new rocket's architecture in this presentation.
We're going to build a big rocket. It's called Neutron. We've been busy. But let me show you a new breed of rocket where reliability, reusability and cost is hard baked into the design from day one. This is not a conventional rocket. This is what a rocket should look like in 2050, but we're building it today. So where do you start designing a new rocket? Well, ironically, you don't start at the rocket. You start at the satellite and all the spacecraft that you need to launch, and then you start the design process around that. Over 80% of all of the satellites that are going to be built in the next decade are going to be small satellites and constellations. And these constellations form a critical part of the infrastructure around the planet to guide, monitor, and enable Earth's future. Constellations require very unique deployment needs, and up until now, there hasn't really been a vehicle that's optimised to do that. But of course, Neutron's not just great for constellations. It's great for geostationary deployments, human spaceflight, and of course, my personal favourite, interplanetary. Now, as we went through the design process, it became very, very clear that this rocket was going to dispense with all convention. This is a reusable launch vehicle, so that means it's got to land. So you don't want any deployable landing legs. You want a nice, big, wide, static base. Next is the upper stage. The upper stage is actually really, really tricky because it has competing requirements. Firstly, it has to be the lightest and the most high-performing structure as part of the launch vehicle, but it also has to be the lowest cost, because for Neutron, at least at this point in time, it's a disposable upper stage. So when you think about making super light structures and super high-performance structures, you need to really put them in tension. So Neutron's upper stage is actually hung from the payload separation plane, which makes it incredibly strong, and it also makes it the lightest upper stage ever in history. Finally, we add tanks to the bottom of stage one and then connect it all together. Now, Electrons taught us a lot about reusability, and reusability and re-entry is not actually a structural problem, it's a thermal problem. So the best way to manage a thermal load is to just not have it. Neutron, a continually decreasing shape and size of the vehicle, starting large at the base to smaller at the top. That's actually really important because what that does is it decreases the pressure along the vehicle. So as we're re-entering the atmosphere, that decrease in pressure ensures that we don't have any shock waves attaching to it. It stands 40 metres tall, it has a 7-metre diameter at the base and a 5-metre class fairing. We can lift 8 tonnes in a fully reusable mode, returning back to the launch site, or 15 tonnes is its maximum payload capacity to low Earth orbit. And the vehicle itself weighs 480 tonnes. So if you stood in front of a rocket in 2050, you wouldn't expect it to be made of normal materials. Weight is absolutely everything in a launch vehicle. Okay then, let's try something new. Let's try carbon composite, but not any kind of carbon composite, a Rocket Lab carbon composite. But sometimes carbon composites get a bit of a tough rap because they're expensive to manufacture and slow. Not the case. We're going to do this fast. We're going to use automated fibre placement. 3D printing really changed the game when it came to rapid manufacture. At least it did in 2013 when we used it to build the first 3D printed rocket engines on Electron. With metallic 3D printing, you measure the speed in millimetres per minute. With automated fibre placement, you measure the speed in metres per minute. We have already shown with Electron that carbon composites are an ideal material for an orbital rocket. Now, thanks to Neutron, it's going to really come into its own as a rocket material of the future. Now, as much as I do love the sleek black look of carbon, it's about far more than looks. A huge reduction in weight is a game changer. If you can take the mass out of the rocket, you take the pain out of propulsion, and quite literally, the heavy lifting. Now let me introduce you to Rocket Lab's newest engine, Archimedes. Now, because we don't have to lift a great big hulking metal rocket into orbit, it means the engines can be far less stressed. We don't need to push the engines to their absolute maximum. Archimedes is a 1 meganewton thrust engine. With over 320 seconds of ISP, its propellants are liquid oxygen and methane, and the cycle is also very simple. It's a gas generator cycle. These are all the things you want when you have to build an engine that can be reused over and over again. There is no point in having an engine that is absolutely busting its bolts at 11,000 psi. What we need for a reusable launch vehicle is an engine that can run over and over again at very low stress and very high margins. That's what's important. 7 Archimedes engines propel the first stage. Since reusability is at the heart of the Neutron design, we asked ourselves, How could we reuse as much as possible to really drive down those costs and time to get it onto the pad and launch again and again? The answer is not throwing away the fairings or even trying to catch them. The best way is to never get rid of them in the first place. Next, we have to control the rocket during re-entry. So that's right, Neutron does not land on a barge, it is a return to launch site vehicle. So to guide the rocket back, we use the shape to our advantage, just like Electron. We use the atmosphere to do as much work as possible. Small control surfaces called canards at the front make small changes in the trajectory needed to get the accuracy and guide the stage back to the launch site where we started. So what lands back on Earth is a complete first stage, fairings and all. And all we need to do is open those fairings back up, load in a second stage and a payload, close the fairings and go again. So what does a 2050 rocket look like? Well, it should be designed to be reusable from day one. It should also have materials that are advanced, materials that can withstand all the forces of re-entry and are cost-effective and easy to manufacture. It should also have engines that are able to be used over and over again, and engines that aren't stressed to their absolute limit. It's really important also to be able to return the vehicle to a launch site, not costly barges way out in the middle of the ocean. And then finally, it's also important not to throw away fairings, but just have a vehicle that you can load upper stages and payloads in and fly again and again and again. And it launches from a pad without all that bulky and costly infrastructure. We did something extraordinary with our first rocket, Electron, and we're doing something even more extraordinary with Neutron.
That's Rocket Lab's founder and CEO, Peter Beck. And this is SpaceTime. Still to come. Starlink under fire for crowded skies. And later in the science report, an exquisitely preserved fossilized dinosaur embryo has been discovered in southern China. All that and more still to come on SpaceTime. Beijing has slammed Elon Musk and SpaceX following two close encounters between China's new Tiangong space station and Starlink's ever-growing constellation of broadband internet satellites. China says it had to maneuver its space station out of the way of the 260-kilogram satellites on two occasions last year in order to avoid collision. The first incident occurred in July, the second in October. The core module of the Tiangong, or Heavenly Palace space station, was launched last year, with two more modules expected to be launched over the next 2 years. Evasive maneuvers to reduce the risk of collisions in space are becoming more frequent as more objects enter orbit. The International Space Station was forced to undertake evasive maneuvers several times last year to avoid space junk, including one incident involving debris from a Chinese weather satellite deliberately blown up by Beijing in 2007 as part of an anti-satellite missile test. Funny how those things come back to bite you, isn't it? Astronomers have long been complaining about the disruptions these dense constellations of satellites are having on important research, and there are growing concerns about the likely damage such crowded skies could cause. Still, December saw Elon Musk and SpaceX launch two more batches of Starlink satellites. In early December, a Falcon 9 launched 48 Starlink satellites, as well as two Black Sky Earth observation spacecraft from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. 2 weeks later, another Falcon 9 launched a further 52 Starlink satellites, this time from Space Launch Complex 4E at the Vandenberg Space Force Base in California. That mission marked a record 11th launch using the same Falcon 9 core stage, and the 34th launch for Starlink. Both missions saw the core stages return safely to the surface, landing on drone ships which had been pre-positioned downrange. Starlink has now launched some 1,944 of its satellites, and it still has plans to eventually operate a constellation of over 30,000 spacecraft. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. An assessment of bird populations in Australia's wet tropics has found lowland species are moving uphill as global temperatures increase, displacing birds that once lived in those areas. The findings, reported in the journal PLOS ONE, looked at the abundances and distribution of 42 bird species between the year 2000 and 2016, finding most birds that lived at higher altitudes have been pushed out of the lower levels of their ranges, with numbers dropping by more than 40%, while the numbers of lowland birds in those areas have increased by 190%. Overall, upland specialised species populations have declined by almost half, as have rare species that are unique to the area. The findings suggest that Australia's Wet Tropics World Heritage Area, one of the most irreplaceable biodiversity hotspots on the planet, is rapidly degrading as the planet warms up. It's been revealed that Australia's intelligence officials informed their US counterparts that they had detected a sophisticated intrusion into the country's telecommunication systems from malicious code embedded in a Huawei software update. The hack, which occurred back in 2012, substantiated suspicions in both countries that China used Huawei equipment as a conduit for espionage. Guided by the Australian tip, American intelligence agencies confirmed similar attacks by China using Huawei equipment in the United States. The newly confirmed intelligence, reported by Bloomberg News, sinks claims by Beijing that Washington's concerns over Huawei equipment were unfounded. Bloomberg's reporting that the security breach and subsequent intelligence sharing was confirmed by some 24 former national security officials who received briefings about the matter from Australian and American agencies between 2012 and 2019. The United States, Australia, Sweden and the United Kingdom have all banned Huawei from their 5G networks, and about 60 countries have signed on to a US State Department program where they've committed to avoiding Chinese equipment for their telecommunication systems. Paleontologists have discovered an exquisitely preserved fossilized dinosaur embryo inside an egg at a dig site in southern China's Gansu province. The embryo, which has been named Baby Ling Yang, was found in late Cretaceous period rocks dating back to between 66 and 72 million years ago. The findings, reported in the journal Science, suggest the embryo belongs to a species of toothless theropod dinosaurs known as oviraptorosaurs. Scientists say the embryo's posture was unique among known dinosaur embryos because its head was positioned tucked below the body, with the feet along either side and the back curled along the blunt end of the egg. This posture has never been seen before in a dinosaur embryo, but it's very similar to that of modern bird embryos. A new study claims wine grapes may have originated in Western Asia. A report of the journal Nature Communications claims domesticated table grapes in Western Asia, combined with local wild relatives, may have been the genetic beginnings of grapes we use today to make wine. Researchers analysed the genome of a common grapevine to try and find its ancestors. They say wine grapes likely originated from a single domestication event, most likely in the southern Caucasus around Armenia and Turkey, before being interbred with various wild European varieties. Among the grapes we now know, the authors say those from Italy and France tend to be the most genetically diverse. Astrology is an ancient form of fortune-telling, a way to make sense out of a world before science was able to decipher fact from fiction, at which point the science of astronomy took over. Today, the scientific evidence that astrology doesn't work is overwhelming. Yet there are still millions of people around the world pushing the practice, usually for a bit of fun, but many do use it to get money from the weak-minded. Tim Mendham from Australian Skeptics says there are good reasons not to follow or believe in astrology.
Apart from the fact it doesn't work, there's various reasons. I mean, if you look at, there's sun sign astrology, right, and there's sort of like planetary astrology and even outside planets. But sun sign astrology is the one we all know, where we have our constellations and our star signs. And the basic issue there is that the sun, there's these 12 star signs, they're constellations as we know them, that run around the ecliptic, which is the line the sun makes through. You guys would know all this anyway, right? Because this is your area. But I mean, the sun travels, if you like, and when a star sign is behind that, when you can't see it, of course, but it's the star sign is behind that, that's your star sign. The trouble is, because astrology has been studied for about a couple of thousand years or more or so, the precession of the equinox means that there's a slight shifting. Because there's a very slight wobble, the wobble in the wobble of the Earth's axis means that the star signs are shifting somewhat over the years. And so that over
Plus
about
there are actually 13 of them.
Well, there's actually 13 star signs. Yeah, there's a 13th called Ophiuchus, which is the snake. But because you're trying to divvy up 13 star signs into sort of patterns and things is really hard, so it tends to be left out. But then, yeah, because of this precession of the equinox, they're actually shifting, and then over 2,000 years, they've shifted through one star sign. So if you think you're Pisces, you're probably actually the one before or the one after, I forget which way it is. So, I mean, when we had the dawning of the age of Aquarius way back when in the Hair musical, etc., that was actually based on the precession of the equinox, that we're actually entering into a new age because the signs are changing. Also, of course, the star signs themselves are not equal. Everyone thinks there are about 12 of them. There's about 30 days or so of space when you're in a particular star sign. That's total rubbish. The biggest one is actually, I think it's Virgo, which is about 35 days. The smallest is Scorpio, which is about 5 or 7 days. So you've got very little chance of being a Scorpio, even though Scorpio has moved along with everything else. So apart from the fact the constellations aren't in the right place and that the constellations are not all the same length and that there's actually 13 constellations in the ecliptic rather than 12, apart from that, astrology is fine.
Well, I think the bottom line is that the idea that the gravity of a distant body has an influence on your personality and character and fate and future doesn't make scientific sense.
No, and people have asked now, astrology is based on the time you're born. Surely it should be the time you're conceived, right? Because that's when you start sort of receiving...
Well, during that whole 9 months, really, as you grow and develop, yeah.
Yes, the thing is, tracking down exactly when you were conceived is a lot harder than when you were born. But someone worked it out that the nerve standing at the back of the theatre when you're born, if you're born in the hospital, has more gravitational effect than any planet does. So, I mean, the whole thing is just primitive assumptions, basically, based on that in summertime in the northern hemisphere in Babylon, where these things were developed, you have the very hot sort of star signs like Taurus, the bull, and that sort of thing, to indicate that this is tough weather. In the colder months, you get the water symbols and things like that. So it's primitive, it's basis. There's no basis in fact. There's no basis in the science. In fact, the science is all totally different and declares it as rubbish.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.